So our objective today, oops, let's go back. Is we're going to review the coordinate plane. Because you will be doing some graphing. But this is different kind of graphing than you had to do before. And then we're also going to talk about, we're going to make sure that we understand relations. And under relations, we're going to understand domain. And we're going to understand range. Now, range is a term we use in statistics, which means the difference between the largest number and the smallest number in a group of data, but we're using it from a different perspective when we talk about relations. Okay, so let's start with the coordinate plane. So I'd like you to copy this, and you're going to add, I'm going to change this to a big C. Oops. Okay. So what makes up the coordinate plane? Well, you got to get, what do you put the coordinates on?
Plane.
It does have 4 quadrants, but what creates the 4 quadrants? The X and Y axis. So that's where we're going to begin. Okay, which one is the X axis? Which one is the Y axis? Okay. X is left and right, or horizontal is the word that we tend to use. So you might want to remember that, horizontal axis. And then the Y is the vertical axis. Okay. Let's go ahead on our axis and let's write the numbers 1 through 5 in all 4 directions. So to the right, 1, 2, 3, 4, 5, and then put in at least every other number. Evens usually is good. And then going up, it's 1, 2, 3, 4, 5, again, every other number. But when we go left, it's -1, -2, -3, -4, -5. So -4 here, -2 here. And then going down, -1, -2, -3, -4, -5. Oops. Okay. Oh, what do we call the intersection of the 2 axes? That's your origin. Good. And then let's name the origin or the quadrants. Kyler had mentioned them. Which one, and how do we number the quadrants, by the way?
Clockwise.
Roman numerals. And we don't number it clockwise. We go counterclockwise, but where is quadrant 1? Because we need a starting point. Giovanni?
Top right.
Top right. So quadrant 1 is right here. Let me change colors. And what kind of coordinates do you see in quadrant 1?
Positive.
In fact, there was a question on the test from yesterday that's all you really needed to do is look at the quadrants that the point was in and then look at the coordinates that were answer choices and you could figure out the answer without knowing exactly. Okay. Then we go counterclockwise. So this would be quadrant 2. Oh, if I could spell today. Quadrant 2. And what are the coordinates look like in this plane?
Negative X or positive.
We have negative x's and we have positive y's. Okay. And then we carry on and we go to quadrant 3 in the bottom left. And its coordinates look like
Negative X
negative x
and negative Y.
and negative y. And then quadrant 4. That's I before V. And what do its coordinates look like?
Negative y and positive x.
So we always have to go alphabetical.
X and negative y.
Positive x and a negative y. Okay? So I'm going to put a point on here, and let's see if you guys can figure out where I put that point. What would we say the coordinates of that point are?
Negative 4, comma 2.
Good. Negative 4, 2. So if you understand all of that, a good half of your homework is going to be a piece of cake. Okay? Because that's what you're going to be asked to do. All right? So that's important to understand how to do graphing. And then what we want to do is to talk about how to graph. So I'm going to give you a series of ordered pairs. Then we're going to make a table out of them. And then we're going to graph them. So we're just going to do that example. So we have a list of ordered pairs. And they would be negative 2, 3. They would be 1, 2, 0, negative 1, 3, 1. In a table, I would write them with titles of x and y. The x's would go on the left under x, negative 2, 1, 0, 3. And the y's would go, corresponding y's would go on the right. So with negative 2 goes a 3 for the y, 1 and 2 pair up, 0 and negative 1 pair up, 3 and 1 pair up. So then I'm going to make a graph of it. And I kind of cater my graphs to the numbers that I see. So I need to go down to negative 1 on the y-axis, up to positive 3. I need to go to the right 3 on the x-axis and to the left negative 2. So I really need to go a 3 by 3 is all I need for my system, or my coordinate planes. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So here's negative 2, here's negative 2, here's 2, here's 2. And so what I'd like you guys to do is just, are you writing anything? Because it looks like you've got your hands crossed and you're just watching. Your job is to take notes. Again? Oh my goodness.
I got one last night too, really bad at like 2 in the morning.
Oh geez.
She's crazy.
No, she's just got a lot of dryness going on. Okay, your job, graph. So go ahead and take a moment and graph those ordered pairs. All right, here's the reveal. You should see the purple dots are the 4 points that are graphed. Over here in quadrant 2 is the first point, negative 2, 3. In quadrant 1, we have the points 1, 2. That's up on the y-axis, towards the y-axis. And then the point 3, 1. That's in the first quadrant. And then we have the point 0, negative 1. What do we call him? He's the y-intercept. It's where it would cross the y-axis. Now, he's not in any quadrant. We would say he's on the y-axis, okay? And that's how we would describe him. Okay, now, what we've just done is what's called a relation, okay? So a relation is just, honestly, a set of ordered pairs that belong together, okay? So that's our next word, a relation. So a relation is any set of ordered pairs. For some reason, they belong together. We don't know the reason, we don't care the reason, we just know that for some reason they belong together. Now, when you see a set, it normally looks like this. You see the braces, and then ordered pairs are listed. Separated by commas, and then it ends up, I'm always lousy at doing my brace on the one side and decent on the other side. Okay? So that's a relation. It's any set of ordered pairs. So our relation contained the ordered pairs -2, 3, 1, 2, 0, -1, 3, 1. Next, we talked about in our objective that we need to understand what a domain and a range is. Well, basically, if you look at your chart is broken down into a list of domains and a list of ranges. So if you look at your table, what do you think might be the domains? I said they're already grouped together as a list of domains and a list of ranges. Okay? Yes, the domain is just all your x values. So the domain of a relation is the set of x coordinates of that relation. So for us, we would just look down the x column and we'd just list them. -2, 1, 0, 3. Order doesn't really matter. You can leave the orders the way that they show up. We don't have to put them in numerical order. We don't have to put them in positives first and then negatives. We don't have to do any of that. Okay, we just simply write them as we see them. So if the domain of the relation is the x coordinates, what do you think the range is?
The Y.
There you go. The range of a domain is the set of y coordinates of that relation. So again, for us, it would be the set that contains the 3, the 2, the -1, and the 1. And again, it doesn't matter the order that we write them as long as we have all of them. Okay? So one of the things you're going to be doing on homework is you're going to be given a relation written as a set of ordered pairs. Not in a chart form, but just as a set of ordered pairs. You're going to be asked to write it as a table, and then you're going to be asked to graph it, just like we did up here. And then you're supposed to list out what are the domain and what is the range. So here's one thing that you can do for domain to signify which set is which, is you could say D, capital D, equals. So D is going to stand for domain. And what do you think you're going to use for your range? R. So you'd say capital R equals. So that would be the entirety of what you would do. Given that set of ordered pairs, write it in table format, graph those ordered pairs, pull out and tell me what's the domain, the x coordinates, what's the range, what's the y coordinates. As simple as that. Okay. So we're going to go into a situation so that you can apply this to the real world. Because why do we need to know this? Everybody good on this? Can I move?
Yeah.
Everybody got everything? Okay. All right, so we've got this situation. A movie rental store charges $3.95 per movie rental. Now, I'm going to give you a scenario of what they tell us to do. Okay? So, scenario 1. Make a table of ordered pairs in which the x coordinate represents the number of movies rented And what do you think the y-coordinate will be? What would the y-coordinate be? Because we've got to pick a number, two numbers that belong together. So if we know that it costs $3.95 per movie, and my x values, my domain is how many movies I rent, what's my y value, my range, going to represent? Justin? Cost of all those movies you're renting, okay? So the x-coordinate represents the number of movies rented, and the y represents, the y-coordinate represents the cost of renting. And now here's where they kind of give you a giveaway, because you're like, oh my gosh, x values, we could rent from 1 to infinity. Okay, well, infinity would be kind of scary. There's a finite number of movies in there, but you wouldn't want to rent that many. But let's give you a limitation. The y-coordinate represents the cost of renting 1, 2, 3, or 4 movies. So basically what we're doing is asking you, we're telling you what your domain is, right? We're saying, here's your x values, 1, 2, 3, 4. Because honestly, that's pretty reasonable. We rent 1 or 2 movies often. There's been a rare occasions we've gone to 3. I don't think we've gone to 4 in a long time. But if you're going to do nothing but watch movies, that would work. Yes, sir.
Why don't you just get Netflix?
Pardon me?
Why don't you just get Netflix?
Netflix doesn't have a very good choice. So what we're going to do is to make our table of ordered pairs. So in the second part, it gave away what we're going to choose for the number of movies. 1, 2, 3, 4. Second part, we're going to have to do some calculations. So it's easy to figure out how much it costs to rent 1 movie. What's that going to be? $3.95. Okay. Next, we're going to have to figure out how much it's going to cost for 2 movies. So we can multiply by 2. 10, and we get 18 and 1 is 19, 6 and 1 is 7, $7.90. Okay. What are we going to get for 3 movies? Well, I could just add $3.95 if I want to do it this way. I get $11.85. What about 4 movies? Well, let's just add another movie on there. We get 17, 18, 4 and 1 is 5, and we get $15.80. Okay. Based on that, I want to create a chart. And do I need to draw the entire coordinate plane to graph these ordered pairs? What part of the coordinate plane would I need to create in order to graph these ordered pairs? Quadrant 1, right? Because that's the only place that has positive coordinates. So my graph's going to look just like this. So if you want, you don't even need graph paper other than to help you keep things organized. And the intervals you use on one axis is not the same as the intervals for the other one. So for example, on the x-axis, I just need a total of 4, right? And that's going to be the number of movies rented. So we have 1, 2, 3, 4. And then our money needs to go basically close to 16. So if I wanted to, let's see, I'm going to go 12, 16. So this is going to be cost of movies. And this is $4, this is $8, this is $12, this is $16. And then I could split those intervals in half so that I could get a little bit of leeway. So this would be $2, this would be $6, this would be $8. Oh, sorry. Try that again. This would be $10, this would be $12 or $14. There we go again, $14. So that's going to help me line things up. And then I just start graphing. So 1 goes with $3.95, which is going to be just below 4. Okay. 2 goes with $7.90, which is going to be just below $8. Now, if we have graph paper, it'd be easier to do because we would have the blue lines of the graph paper line things up. Let's see, three movies is going to be under 12. And I have 4 movies is going to be under 16. Now, what kind of, if I connected those, what would you say is true about those? It's constant increase, right? Because the cost of the movie didn't change. It was the same every single time. Okay? So that's basically what you guys are going to do on your homework. Okay?